So Dr. White,
Yes.
first of all, thank you for having me in your lab.
It's a pleasure.
It's a while since I've been on this floor in the physiology department. Tell us about the physiology department and what you do here.
The physiology department. Well, it's a very, very diverse department, but it is also a department that works fabulously well as an academic unit.
Yeah.
Remarkably, we all get along very well. It has a very heavy teaching component. Everybody does their job. The research interests are extremely diverse. So this laboratory, in a certain sense, represents one of the fringes of the physiology department because we're in a physiology department, but we do molecular biology, molecular genetics, genomics.
It's very
et cetera.
multifaceted, yeah.
Right? And then there are other laboratories that do systems neuroscience and study vision in awake animals and things like that. So it's an extremely wide range of research interest, an extremely wide range of research techniques that are used. And yet, we all get along, we all respect each other, and I've been here since 1991. And I have, since 1991, never had to deal with any sort of peripheral, political nonsense that can go on in certain places.
People are here because it's a life's work, and I think this is
and also, to be honest, in this department, there's a real sense of family.
Yeah.
And it's something we tried to cultivate, and it's still very strong to this day.
So let's go back to the research a little bit, and what kind of research, when we walk around and I speak to the researchers and the scientists that are here, what kind of research is happening here? What are we researching?
Well, a number of things. There is a very strong neuroscience component in the department, and there's neuroscience and neuroscience. So, as I said, we have what I call systems neuroscience people who are studying vision in awake animals. There are other people who are doing sort of much more molecular neuroscience, understanding at the very cutting edge research into how the electrical signals in the nervous system are transmitted, the type of molecules and sensors that, for example, control our capacity to detect pain and deal with pain and things like that. There are other people, as I said, I'm a vitamin D biologist and I don't do any neuroscience at all. There are other people who study muscle function. There really are a vast range of interests in the department.
So today, given our, renewed commitment to learn more about ourselves, the way we perform, the way we digest and think, why physiology today more than ever? Why is it so important today?
Well, I mean, it's funny. The more we learn, the more we realize we don't know, and that we have to learn more about. And so, for example, one of the frontiers of physiology, and one of the things that I want to try and build over the next few years as chair of the department, is, for example, how the microbiome, the microbial contents of particularly your intestines, etc., but also elsewhere, actually control your physiology. We know that there are interactions between the microbiome and the immune system, but that's only a small aspect of physiology. There are many other things that are likely controlled by the microbiome, and that, to my mind, represents one of the frontiers in one of the fields of physiology.
And that's a lot of the answers for us lie in that microbiome.
We'll have to see, but there's definitely, we now know enough to know that there's a lot to be explored there.
And that we should continue in that area.
Absolutely.
I look forward to what's next. Thank you for giving us the time and for the tour.
It's a real pleasure.
And it's good to be back. Thanks, guys.